Hello everyone, I am Dr. P. Kumari, working as an Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, I want to discuss about problems on Gauss Divergence Theorem. So, in the previous video, we discussed about what is the Gauss Divergence Theorem, what are the problems, what type of problems will be there by using Gauss Divergence Theorem. So, what are the inner basic definitions and formulas we should know to solve this type of problems we discussed. So today I am going to give some of the problems how we can solve by using Gauss Divergence Theorem and how we can verify the Gauss Divergence Theorem. So see here, first problem, verify the Gauss Divergence Theorem for f bar equal to x square minus yz into I, y square minus xz into j, z square minus xy into k over the rectangular parallelepiped. So rectangular parallelepiped means we can imagine cuboid here. So based on this we can identify about the surfaces. So here they are giving the x limits are 0 to a, y limits are 0 to b and z limits are 0 to c. Otherwise, they can ask the same problem like this also. Verify Gauss Divergence Theorem for f bar equal to x square minus yz into I, y square minus xz into j, z square minus xy into k over the rectangular parallelepiped. They can give the values like this also. X equal to 0, x equal to y equal to 0, y equal to b, z equal to 0, z equal to c. So if they given like this also and 0 less than or equal to x less than or equal to a, or x equal to 0 and x equal to a, both are same. So that's why you should know about the what is the problem, how we can do. So already I told you, if it is there, verify means we have to do the two parts, LHS part and RHS part in the Gauss Divergence Theorem. For example, here in place of verify, if they are asking using Gauss Divergence Theorem, then we can do any one, surface integral also or volume integral also. So based on the problem, we have to give the solution. So here, first, what is the statement of the Gauss Divergence Theorem here? So Gauss Divergence Theorem is double integral over S f bar dot n bar ds equal to double integral over v del dot f dv, del dot f dv. This is the statement of the Gauss Divergence Theorem. So here to calculate the RHS part, first we should know about the del dot f. So given, first I am writing the given data, given f bar equal to x square minus yz into I plus y square minus xz into j plus z square minus xy into k. Here what is the del operator already we know, that is I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So now we are doing the del dot f value. What is the del dot f here? Dot product we are doing. Here f I coefficient is x square minus yz. Here I coefficient is dou by dou x. So I dot I is 1. So finally we are getting here del dot f equal to dou by dou x of x square minus yz. Next, plus now j coefficient here y square minus xz, here dou by dou y. So dou by dou y of y square minus xz plus third element here, so k coefficient, and here also k coefficient, dou by dou z of z square minus xy. Now we are doing the differentiation here partially with respect to x, first one. So here first with respect to x square, dou by dou x of x square is 2x. Remaining y and z are constant, so that is 0. Plus dou by dou y of y square, this is 2y minus 0. Next dou by dou z of here with respect to z, so this is 2z minus 0. So finally we got the value 2x plus 2y plus 2z. We are taking the common here, 2 into x plus y plus z. So this is the value of del dot f. So del dot f is 2 into x plus y plus z, x plus y plus z. Now we are substituting here for the RHS part. RH is equal to triple integral over V del dot F into dV. So what is the del dot F value we got here? 2 into X plus Y plus Z. So this is the value. So when you are moving to let the integral, we should know about the X limits, Y limits and Z limits. Already in the problem they given X equal to 0 and X equal to A. So here Y equal to 0 and Y equal to A. And Z equal to 0 and Z equal to A. So how we got this in the problem? They mentioned 0 less than or equal to X less than or equal to A, 0 less than or equal to Y less than or equal to B. Sorry, here this is B, this is C. So 0 less than or equal to Z less than or equal to C. So these are the limits they given in the problem only. So otherwise they can give like this also: X equal to 0, X equal to A, Y equal to 0, Y equal to B, Z equal to Z, Z equal to C. So based on this, Z limits are 0 to C, Y limits are 0 to B, X limits are 0 to A. So based on this, we are evaluating the integral. So here integral 0 to C, integral 0 to B and integral 0 to A. So these are the Z limits, these are the Y limits, these are the X limits. So into del dot F value is 2 into X plus Y plus Z into here first dx is there. So dx, dy, dz. Here three elements are, X, Y, Z. Three limits are constant. So that means we can do first dx also, dy also, dz also. Anyway, we can do dz, dy, dx also we can do. Dy, dx, dz also we can do. Because three limits are constant. If the limits are variable and constant, then we have to do first variable limits, after then constant. Final value should be constant only. So now I am doing first with respect to x. So 0 to c. Here 2 is the constant taking out. So integral 0 to b. Now we are doing with respect to x. So 2 into integral x is x square by 2. Plus y is the constant, integral dx is x. Plus z is the constant, integral dx is x. Limits are 0 to a. Remaining dy dz. So now 2 will be cancelled. Here 2 integral 0 to c, integral 0 to b. Now we are replacing the limits. Upper limit minus lower limit. So a square minus 0 is a square. Plus y into a minus 0 is a. Plus z into a minus 0 is a. So finally this is a square to integral 0 to c, integral 0 to b, a square plus ay plus az. A square plus ay plus az. So here now we are going to do with respect to y first. So 2 integral 0 to c. Now I am doing with respect to y. So a square. Here integral dv is y plus a into integral y is y square by 2 plus a into z also constant, integral dy is y. So limits are 0 to b, 0 to b and 0 to b into dz. 2 integral 0 to c. Next integral 0, here we got a square by 2 into y plus a y square by 2 plus a z y. Limits are 0 to b into dz. So now I am substituting the limits. 2 integral 0 to c. So a square by 2, y limits are b minus 0. Plus here also a by 2 into b square minus 0. Plus here also az into b minus 0. So finally dz. Now 2 integral 0 to c. So a square b by 2 plus a b square by 2 plus a b into z. Now we are doing with respect to dz. So 2 into a square b by 2 integral dz is z plus ab square by 2 integral dz is z plus ab into integral z dz is z square by 2. Limits are 0 to c. Here also 0 to c. Here also 0 to c. Now we are substituting here 2 into a square bc by 2 plus ab square c by 2 plus abc square by 2. So these are the values we are having. Now when you are simplifying this, we are getting abc into a plus b plus c. This is the value of triple integral over v del dot f dv. Triple integral over v del dot f dv. Now we are going to calculate the LHS part now. So you can see here in the LHS part we are getting the 6 faces. For the rectangular shape we can imagine the cuboid here. So here what are the faces we are having, we can observe and we can take here. So 6 faces. How many faces? 6 faces. So here if you are taking this is S1 and S2, S3, S4, S5 and S6. So here these are the 6 faces. So now if we are having 6 faces, we have to evaluate the integral for the S1, S2, S3, S4, S5 and S6. So along each phase we have to calculate the integral value. So that's why first we are taking S1. S1 we are taking as a bottom. So S1 we are taking as a bottom. So S1 if you are taking bottom, that will be in the XY plane. That will be in the XY plane. This is the X. This is the Z. So XY plane. S1 is in the XY plane. So that means we have to take TS as TX dy. So here we are taking bottom. This one, if it is in XY plane, remaining Z, it is K bar. So we are taking this one is minus K bar. So then here F dot n value is minus z square minus xy. According to F here in the problem, they given x square minus yz, x square minus yz, x square minus yz into I plus y square minus xz, y square minus xz into j plus z square minus xy into k, z square minus xy into k. So now for the f dot n is here we are taking n cap is minus k bar. So here remaining I dot k is 0, j dot k is 0. So k dot k is 1, remaining minus of z square minus xy, that is only we wrote here. And on xy plane, z value is 0. On xy plane, z value is 0. So we are taking here z equal to 0. So f dot n on x, we are taking xy plane. So here xy value. Integral 0 to b dx and dy only we are taking for the ds value. So that means we need to take the limits of x and y only. So we know, so x limits are 0 to x equal to a, y limits are 0 to y equal to b. So based on this we are writing integral 0 to b, integral 0 to a. Here xy function dx into dy. This is the plane xy dx dy. Again, now in place of xy we are writing here z square minus xy actually. But here z value, what is the z value? 0. So we are replacing 0, remaining minus into minus plus, we are getting xy. That's why we got xy here. Next, coming to S2, we are taking S2 as a top. This is also in the xy plane, so that's why. But here, this is upper value. So z is c. So here z equal to c, and here we are taking dx dy. And here the bottom surface we are taking minus k. So here that's why we are taking plus k. So opposite sides, one we can take positive, other one we have to take negative. So if you are taking here positive, you have to take here negative. If you are taking here negative, you have to take here positive. So that's why we got here the value z square minus xy and z equal to c. So based on that, f dot n value here. So we got actually z square minus xy. So what is the z value? Z value is c. So c square minus xy. We wrote here c square minus xy. So this is the f dot n value. Already here we are replacing this value c square minus xy into dx dy. Limits are 0 to b and 0 to a. So 2 s1 and s2 over. Now we are taking s3 where left. This is the s3. So x3 is in the plane yz. S in the plane xz they are taking here. So if it is xz here, y will be there. Okay. So here, if you want, you can take here xz also, here yz also. So anyway, based on that, we'll get the value. So here xz, so dx dz. So here this one I am taking as minus j bar. That means that opposite side you will take it as j bar. So here minus j bar. So when you are taking n cap is minus j bar, then first term is 0, third term is 0, only we will get the second term, that is y square minus xz. That is only we got here minus y square minus xz. On xz plane y is 0, so y equal to 0. So here if y equal to 0 means finally we got xz. So xz. So finally integral 0 to c, integral 0 to a, xz into dx dz. Now we are moving to S4. S4 we are taking here. So before we taken minus j bar. So now we will take plus j bar. So this is xz plane only. So dx dz. So when you are multiplying with n cap j bar, we are getting here y square minus xz. So y along this value is p. This is c. This is x, right? This is e, and this one is p. So now based on that, here we are taking y value is p. So here y value is b means we got here b square minus xz. In place of function we are replacing b square minus xz into dx dz. So now we are moving to S5 and S6. So observe this figure. So what they are giving here, S5 is back. S5 is back. So here we are taking, this is S5, this is S5 and this is S6. So here we are taking, this is in the YZ plane, that means X I bar. So we have to take, so YZ plane, so d by dz minus I bar. So minus I bar means here we will get the value minus x square minus yz value we got when you are doing the dot product. So on xyz plane x value is 0. So that means we will get here, in place of x we are replacing 0. Finally we got here yz dy dz. So y and z limits are 0 to c and 0 to b, yz dy dz. Now we are taking the s6. S6 is here. So front value. So this is I bar. Before we taken minus I bar, right? So now we are taking I bar. So dy dz. So yz plane. So x square minus yz value we got. So if it is here 0 means x value is a here. So in place of x we are replacing a square. So a square minus, actually this is x square minus yz. So x value is a now. So a square minus yz. Now we are doing the integration, integral 0 to c, integral 0 to b. A square minus yz into dy dz. So now we are going to evaluate these integrals first. So actually what we are doing, first we are calculating the integral value for the surface, each surface. After then we can add all those surface to get the total surface of the rectangular parallelogram. So just we are taking the integral value. Now we are going to evaluate the integral value. First S1, f bar dot n ds value we got here, integral 0 to b, integral 0 to a, xy into dx dy. So what is this value we are going to evaluate now? So integral 0 to b, integral 0 to a, xy into dx dy. So these are the x limits, these are the y limits. First we are doing with respect to x. So integral 0 to b, y is the constant, integral x dx. What is the integral x dx? X square by 2. Limits are 0 to a into dy. Next, so 1 by 2 is the constant, taking out integral 0 to b, y into, this is a square into dy. So finally a square by 2, integral y dy. Integral y dy is y square by 2. Limits are 0 to b. So finally A square by 2 into B square by 2. Final answer is we got here A square B square by 2. This is the value of first one. This is the value of first one. After then we can evaluate this integral. So this is integral 0 to b, integral 0 to a, c square minus xy into dx dy. So here integral 0 to b, integral 0 to a, c square dx dy minus integral 0 to b and 0 to a, xy dx dy. So if you calculated, you can replace the value. Otherwise, if you simplify it like this, so this value and this value will be cancelled. Finally, we got integral 0 to b, integral 0 to a, c square dx dy. We can do like this also. Otherwise, we can separately integrate this function and we can integrate this function. We can add those values also. Here, if you are expanding this, we are cancelling these two terms. Finally, we got this one. So here, c square is the constant, taking out integral 0 to b, integral 0 to a, dx dy. So now first we are doing with respect to x. So c square integral 0 to b. So integral dx is x, limits are 0 to a into dy. Now c square into integral 0 to b a into dy. So a also constant, a c square integral dy is y, limits are 0 to b. So now a b c square, that is only we got here for the S1 and S2, summation of surface S1 and surface S2. Now second one, we are taking third surface and fourth surface. So third surface integral value, integral 0 to c, integral 0 to a, xz dx dz, plus integral 0 to c, integral 0 to b square xz dx dz. If you expand like this, integral 0 to c, integral 0 to a, xz dx dz, plus integral 0 to c, integral 0 to a, b square dx dz, minus integral 0 to c, integral 0 to a, xz dx dz. So these two will be cancelled. Finally, we got here integral 0 to c, integral 0 to a, b square dx dz. Now b square is the constant, taking out integral 0 to a, integral 0 to c, dx dz. Now b square integral dz is z. So integral 0 to a, integral dz is z, limits are 0 to c. So now b square integral 0 to a, c into dx. Now c also constant, taking out integral dx. Integral dx is x, right? So 0 to a. So now b square into c, this is a minus 0. Finally b square ac. This is the summation of surface 3 and surface 4. Now we are calculating surface 5 and surface 6. So for the surface 5, integral 0 to c, integral 0 to b, yz dy dz, plus integral 0 to c, integral 0 to b, a square minus yz dy dz. So now we are simplifying this one, integral 0 to c, integral 0 to b, yz dy dz, plus integral 0 to c, integral 0 to b, a square dy dz, minus integral 0 to c, integral 0 to b, yz dy dz. So these two will be cancelled. Finally, I got here integral 0 to c, integral 0 to b, a square dy dz. So now we are simplifying this one. Integral 0 to c, a square is the constant, taking out integral dy is y, limits are 0 to b into dz. Now a square, so b minus 0, integral 0 to c, b minus 0 into dz. Now b also constant, taking out integral dz is z, limits are 0 to c. Finally, we got here a square bc. So the third surface and fourth surface value is b square ac. Here fifth surface and sixth side value is a square bc. Now we are adding all the surfaces here. For the first surface, we got s1 plus s2. What is the value we got here? s1 plus s2, c square ab. What we got here? C square ab, plus s2 plus s3, b square ac, This value is b square AC, b square AC. Plus third one we got a square BC. What we got here? A square BC. Here c square AB plus b square AC plus a square BC. From this we are taking the common a, b, c. So when you are taking the common a, b, c in the first term, so we have c. Plus in the second term we have b. In the third term we have a. So finally this value is abc into a plus b plus c. This is the value of double integral over s a bar dot n ds value. So this is the LHS part. What about the RHS part? In the RHS part also, in the RHS part, we will integral over v f del dot f dv value. Del dot f dv value we got ABC into a plus b plus c. So here for the LHS also we got same. In the RHS also we got same value. So that means double integral over s f dot n ds is equal to double integral over v del dot f dv value is equal to abc into a plus b plus c. So that's why these two are equal according to the Gauss Divergence Theorem. So in the statement what they are telling, these two values are equal. So here we proved from the problem. Hence, we can say that Green's theorem is verified. Green's theorem is verified. So, I hope you understand this problem. So, to get the better clarity, I am moving to one more problem we can observe here. So, same verify. Here also we have to verify the Gauss Divergence Theorem. Divergence Theorem, if they are asking Divergence Theorem also, nothing but that is Gauss Divergence Theorem only. For 2x minus j into I plus x square y into j minus x z square into k over the cube. Bounded by cube means before we take in rectangular parallelepiped. Here cube means all faces are equal. All faces are equal like this. So here x limits are x equal to 0 to x equal to 1 and y equal to 0 to y equal to 1 and z equal to 0 to z equal to 1. So here also we can see same model. So we have to calculate the RHS part, that is del dot f value, and we have to calculate the f bar dot n bar ds value also. If both are equal, then we can say that is the verified. So in the previous problem we got here x equal to 0 and x equal to a, y equal to 0 and y equal to b, here z equal to 0 and z equal to c. So in place of a, here we are having 1, in place of b we are having 1, and in place of c we are having 1. So before that one is rectangular, so that's why these values are different. Now it is cube, so that's why we are getting the all ones. That means all values are equal. So in the same procedure we can follow to calculate here. So here we will get the del dot f value is like this. When you are evaluating the integral, we are getting for the RHS part 11 by 6. If you follow the same procedure for the second part, that is LHS part, integral over s f bar dot n ds. So here same first for the each surface we will calculate the integral value. After then we can add. So we can follow the same procedure what we calculated in the previous problem to know about the surface 1, surface 2, 3, 4 and 5 and 6. Then we can evaluate this integral as like this. So here S1, surface 1 and surface 2 we got minus 1 by 2, and surface 3 and surface 4 we got 1 by 3, and surface 5 and surface 6 we got 2. So when you are adding all these surfaces, we are getting the 11 by 6. For the double integral over f bar dot n bar ds value is 11 by 6. Before in the RHS part also we got double integral over v del dot f dv value also 11 by 6. These two values are equal. So we can say that hence Green's theorem is verified. So in the same way, just in place of x, y and b we are having 1s. In the previous problem we are having ABC. That is the difference, and function is different. So I hope you understand this problem. Please do this problem. If you have any doubt, you can go through these references. So engineering mathematics textbook written by IKV Iyengar and same engineering mathematics textbook written by B.S. Gravel. If you want, you can go to the one more references also. B.V. Ramana, author name, the same engineering mathematics textbook, and you can go to some of the Google links here. So you can get the better clarity, and you can solve so many problems if you follow these references, if you follow the video also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.